Okay, hello. This better be good because it's the last session and you've had already probably your heads full with content. And there was a wonderful presentation of Jurassic Park just before me, and it's really hard to present after that. You guys are making wonders, and it's so inspiring to be at SIGGRAPH. So my name is Tanja. I work for Autodesk for the last 15 years, and I've been in the product management of many creative design solutions. In the last 2 years, I'm in a team that is called Reality Computing, that is dedicated Autodesk team to create solutions that make sense out of captured sensor, captured reality. So we have two lines of products. Recap, that is more focusing on creating, on capturing and integrating reality data into design process, and it's more oriented towards architects, engineers, civil, infrastructure, etc., and around laser scanning and point cloud workflow. And another line of products, which is Memento, which is the topic of today. With Memento, we aim to create high-quality assets from any captured reality. As you know, until now, creating assets for film or games or architecture or anything until very recently was just by modeling from scratch. Well, sensors now have become so ubiquitous and so strong and so smart that actually they can capture the analog world and translate that into the digital world and really start to create assets that are of a quality that you would accept. So with Memento, we wanted to solve 3 problems. Number 1 is, when you create a mesh from captured reality, from photos or from laser scan, those meshes are so huge that nobody can really read them, let alone pleasurably work with them. And sensors are only becoming better, so we will have a lavine of sensor data coming towards us very soon, and very few solutions that have been created for modeling can handle that properly. Another one is we realized that to really get a meaningful asset of a high quality from sensor data, you really need to go through many different software, have a big know-how how to do that, and probably have to have 6, 7 different solutions. This is not moving. Sorry. Hello. We have to wait. PowerPoint is not behaving. By the way, it's also chopping a little bit off the screen. Okay, so yeah, the second reason was the workflow was so complicated. We said, why don't we try to build one solution that makes everything from any reality capture up to high quality mesh. But the third one was also that we realized that not only the usual suspects, architects, engineers, or media entertainment artists are interested to create something with reality, but many other industries, museums, medical experts, archaeologists, artists, scientists, they realize that they can push their professions by digitizing the world that they deal with and educate with it or do something more meaningful with it. So those were the 3 reasons why we made Memento. So what is the feature set of Memento? This PowerPoint is not behaving. I'm so sorry. So number 1, when you look at the workflow, we can read input from any sensor data. Today, it's mainly around photogrammetry. We have in alpha testing laser scan to mesh and also structured light to mesh. The point is we want to be agnostic to any type of sensor data. We create high quality mesh from that, and then we have really smart and super easy to use tools to clean up the environment, to find all the problems, particles, tunnels, holes, etc. on a mesh. Then some other tools to inquire and reach, and then the biggest value of Memento is actually optimizing those meshes for either fabrication workflows, so you can 3D print, CNC, make cardboard replicas, etc., or for digital workflows for VR, AR, game, film, or mobile and web. We also work on a solution to leverage those assets for interactive experiences online that I will talk a little bit about later. So the first thing is we're agnostic to input. Today we have high quality photo to 3D. You know, when I started a couple of years ago, I was asked to run a product about capturing reality, and they said, nah, those things don't work. You know, there was a dramatic big difference in quality from a couple of years ago and from today. It's really amazing, even with the same photos, with new algorithms, how better the models are, let alone when you think about capturing with the new cameras and with the new sensors. So there is a complete quality improvement on all levels, hardware and software. We have Artec scanner to mesh. You can plug in an Artec scanner in Memento and live see the capture. It's not yet perfect because the SDK is not yet enough open, but we're working on that. And we have in alpha by invitation only laser scan to mesh in Memento. What's super important is that we did not build Memento on top of any other product. We built it from scratch, from zero, because we realized we need a super strong mesh streaming engine that can read billions of polygons. And we really did that. It took us almost a year to just work on that engine. But we know that this is just the beginning. The sensors will be so ubiquitous, and they will capture so much data, we will have to deal with it. And Memento is ready to deal with that. So when you look at the UI, by the way, for the format of the presentation, I thought to give you just a very quick overview in a PowerPoint of the whole concept of Memento, then do a live demo, and then show you some super exciting examples of what customers are doing, both from your world, but also from the science and museum and art world. So the first thing that you will see when you open a model that is generated, it will display the camera positions. We also export the camera positions, but today we only see them. What we're working on, obviously, is the usefulness of those cameras to be able to reproject the photos through the camera when you have issues with the mesh, etc. We then created a tool set, really easy to use, but super powerful, almost like a 3D Photoshop-like, to clean up, to select, to fix, to slice the data. And as you will see throughout the demo, one of the first things that users recognize about Memento, it's fun to use and it's easy. And we managed to do that only because we took as a target all those professionals who are not geeky on 3D world. They don't know anything about your 3D modeling world. And we took them as a target user, but in the quality, we didn't do anything less than what you actually need for your work. We started adding mesh editing tools, started with some smooth brushes, sculpt brushes, but we have also already some smart bridge tools that recognize the topology and offer smart ways of connecting edges. And then some additional tools that help you for 3D printing. We also have strong re-topologize or decimation tools. At the moment, we have retriangulation and subdivision that works on selection, and decimation that is very good, but it's global. We understand from many of you that you need also local decimation, meaning just on a selection, and we're, as we speak, working on that. We work through different visualization modes, bunch of reporting tools, setting coordinate systems, setting scale, ortho mode, and then we measure distances, surfaces, volumes of the meshes for different purposes. Working with some underwater marine scientists, we realized that one of the tools that they needed was a comparison tool between meshes that are taken over time so that they can tell if, for example, a coral reef is shrinking or growing and if it's healthy or not. So we built a first tool of comparison, but we are now rebuilding it much better as a mesh alignment tool, but this works. And then we realized that many users are starting to be entrepreneurs around the whole concept of 3D printing and realize that making 3D assets for 3D printing is easiest way is to capture them if you don't know how to model. So we built in 3D printing functionalities. The algorithms will find all the problems around the mesh and offer either automatically to fix them or offer manual tools to fix them and prepare them for printing. We have about 15 printer drivers included, so you can recognize the size of each printer, you can see how big you can print in certain printer, and then save the settings of that printer. It looks a little bit like this. One thing that is really crazy is that we can generate 1 billion polygon meshes, but then you want to 3D print them and you have to dumb them down thousands of times in order to be able to print it because the printer's software cannot handle a high poly count. So for that, we started actually working on supplying the 3D printers directly with the slices so you can actually print the high definition model that you generated and not some dumbed down replica of that. The Autodesk first 3D printer, Ember, already does that, and we're trying to work with the bigger manufacturers of 3D printers like Stratasys Object to actually see if they would allow us to directly ping their printers and such and allow for high resolution 3D printing. The biggest value of Memento is here, is the preparation for export. That is where Memento understands where you want to go. We export in FBX, OBJ, or OBJ with quads. The FBX contains the camera information as well. And when you decimate, we have tools to rebake the diffuse displacement normal map, and in the next release also the occlusion map, so that huge meshes can be made really small and still super smart and super beautiful to look at. And we have other export types that are more standard. And finally, because we were looking at customers who are not always savvy to make beautiful videos, but they do need them to present data, scientists, archaeologists, museum curators. We made some really quick ways to make key frame videos where something like this, where you know how to do this in Maya and Max, but for people who never can use Maya or Max, it's a couple of clicks in Memento to make something that moves from a mesh to X-ray view, to textured mesh, etc. So how Memento is set up, it's what we call cloud-enabled desktop software. What that means is that it's desktop. Currently it's on Windows, and I'm proud to announce at SIGGRAPH that starting next week we have the Mac version as well. So anything that is about cleanup, inspecting, fixing, scaling, baking, decimating is on your machine. It's on the desktop. We only use the cloud for processing the photos to mesh or the laser scan to mesh. Today, that does not seem very fast because we're not doing the real distributed processing, and also because Amazon, until very, very recently, did not have machines that can at all handle our data. So distributing to Amazon was not an option. We could just push to Amazon the small jobs. But now, since last week, we started to burst to big Amazon machines. And when we do the real distribution, it will be in about 4 or 5 months. This will be really fast. Today, it can take from, depending on the number of photos, from 5 hours to 10 hours to receive back the mesh from the cloud. But it's still worth it because the quality is really high. So at this point, I'll switch to the live demo. And I will not use my machine, which makes me very nervous. I will use these beautiful new HP machines that I did not have time to test. So if it doesn't work, it's not HP's problem. It's just a lack of testing time problem. So this is the Winged Victory made by an artist, Cosmo Venman. It is done from photos. When you take a look at the mesh report, it has 26 million polygons. And as you can see, the software is super responsive. If we can take a look at the mesh itself, people don't believe that this can be done with photos. Everybody thinks it's a laser scan. The engine is just starting to get really, really good, and I'm very proud of what we're doing with this. But let's start from the beginning. Let's say you open Memento, and you see something like this. Well, maybe your one will not be this messy with so many projects. These are all the projects that I've worked on. So the first thing you want to do is, OK, I want to actually create 3 different photos. So what do? I go to create 3 different photos. It asks me where are my photos. They can be on my local machine or on a cloud drive that you get for free when you sign up for Autodesk, free account. You have to be signed in for creating the 3D model. But you can also use Memento for meshes that you've already generated in other software. You can generate your mesh in Artec with a scanner and then import it if you want to leverage the rest of the quality, or you can generate in any other solution, or you can even import meshes that you have modeled if you find the value of Memento's preparation tools. So let's say my photos are on the cloud drive, so I'll look for them. These are photos from a dragon that a colleague of mine has taken. I'm not going to load all of them because I want to show you more and not waste time on that. So I'm loading the photos that I took. I took photos all around the object, right? And in this interface, this is the last moment to see if I have any wrong photo here, if something is blurry, if a dog passed by, or somebody, or my finger was in front of the camera, etc. But this is just the beginning. We are working on tools, automatic tools to report if you have blurriness or strong contrast or anything that we know will not help your reconstruction. But we also made local validation of the tools, of the photos. What that means is that we can run that local validation. It will go through the photos, and it will tell you, look, these 10 photos will not stitch. If they were important, you better find where did you miss the link. And very often when, especially for beginners, when you take photos, sometimes either because of strong contrast or because of forgotten overlap, there is a cluster of photos, and then the rest 20 photos are not stitched. So you will at least see it here and say, oh, I'm missing a couple of photos, and then add them and then go. So once everything is OK, all really you need to do is say create model. At that point, it will ask me to log in on the cloud. I will not do that now. You just give a name, and that's it. So in the meantime, you can work. What you cannot do is just interrupt the upload process of the photos. The moment the photos are up on the cloud, you can close Memento and do whatever you want with your computer. It's not locked to the processing process. That is one of the advantages of the cloud. And after a couple of hours, or maybe the next day, you will receive an email that your model is ready. And what you will receive is something like this. So this is the first confusion and frustration of everybody. And they say, Tanya, your software does not work. Because what they get is this absolute mess that looks like nothing. It was a dragon statue, and now it's this kind of exploded environment. Well, actually, the statue is well here, and it's absolutely beautiful. And never get fooled by something that has a texture. Always turn to a triangular view to see the mesh. This was done a couple of weeks ago with the latest Sony pocket camera. It's just unbelievable how spoiled we are and what kind of technology we have in our hands today. I'll show you even some captures that are done with iPhone, and it's unbelievable what's possible today. So these are the different visual modes, by the way. You can switch to X-ray mode. X-ray is kind of X-ray, it's not really X-ray. Photogrammetry is line of sight technology, so it is still the surface, but sometimes it looks good for presentation purposes, so we added that. And then we can do the texture. So let me run through a couple of different data sets to show you some of the different values of Memento. So let's say this is another data set of Garuda. It's made also by one of the Memento developers. So the first thing we want to do is get rid of this environment that we're not interested in. We're just interested in this asset, right? So what I'll do is I'll reorient. And I have selection tools, rectangle or lasso, brush or individual face. I can use the rectangle tool and just say, I'm only interested really in this part. So then I can either say, eliminate everything that was not selected, or down here, say, invert the selection. Both of the methods work. This I didn't show you. It's about 11 million polygon mesh, and it's super quick to do this. The second thing is, what I first always do is reorient the mesh in space. I have no idea how I took the photos. The photos definitely don't know where is the sky, where is the soil. And we did not want scientists and museum curators to have to know X, Y, Z and to get all confused about it. We just asked them, well, where is the up? And you can orient here. This one seemed to be in a good direction, so I don't need to orient. But if I did reorient it, I can then say use current view. And the second thing is, well, how big is this? Usually in computer, you don't care, but the moment you want to print it or you want to bring it in another software, you would care. So there are a couple of methods. The manual method is simply, hey, I know that between this eye and this eye, it's about 10 centimeters, so I'll just type 10 and the unit and then set. From now on, it's correct. We do intend to provide you with targets that you can print and use in the scene, and then maybe automatically calculate also the scale. We know all of these things. I mean, the product is still in beta, so we have a lot of things to do. But this would be the one thing. The other way is to just put a ruler or anything that you know the size of in the scene, and you can always also measure that. Now, obviously, I was not under the earth, so almost every photogrammetry will have some hole underneath, right? And that is now where you will see how we started developing tools that really are just focused, dedicated on making assets from capture. It's so easy when you make software to get into the mode, oh, let's add this and let's add this. We said no. We want to keep it super simple and super easy to use, and that's why we're very disciplined to only put tools that are useful for making assets from reality. So in this case, I just need a tool that slices and that caps it, because let's say I'm interested in just creating a clean asset that has a base. In that case, I'm using the slice and fill tool. I can turn off the ortho. And what this allows me to do is go up and down and then slice wherever I wanted. But if the plane was not necessarily parallel to how you wanted to slice it, you can use these blue dots. 3 dots create the plane, right? And then define the slice plane wherever you really wanted to have it, and then start slicing. And the moment you decide where you want to slice, in the space, by the way, you can slice up or down. I'll just go a little bit further down. Let's say I'm cutting it here. I can pick to fill it, immediately to cap it, or to leave it open. In this case, I'll just say, well, cap it because I want a clean, closed-up asset. And it will do that very quickly, or less quickly, depending on the size of the model, right? But all of these things were super complicated to do, and it's really just as easy that we wanted to provide to make it happen. Okay, so let's imagine that this is something that I want to put in Stingray, in Unity, in any of the virtual worlds. The first thing is, let's check the size of the mesh. The mesh is now 7.5 million polygons. I'll turn on the mesh so you can see. Here, we have some tools for retriangulation or subdivision, but maybe I'm just interested to decimate. But very often when you decimate in software, you don't know how it will look like. You only see how it will look like after you export it. So we wanted to provide decimation tools in Canvas so you can see if I want to decimate up to, let's say, 3.5 million polygons and say apply. I will wait a little bit, but then I will see exactly how it will look like. And if it is not good enough for me, or it's too much or too little, I can then make a decision before actually spending time to export the model. This, again, will take a minute, depending on the size of the model that you want to do. But it will be a preview in Canvas. We also have an option, best geometry. If you're not interested in the texture and you're just interested to decimate for 3D printing or something, then we can do a better job at decimation, take more care about the topology. So let's wait a little bit. It's still a 7.5 million polygon decimation. And by the way, during any of the operations, you can still inspect, change the visual styles, etc. You don't have to sit and wait. I could have picked a smaller one just to show you quicker, but let's give it a second. Okay, this doesn't usually take this long. I'm usually making this. Okay, so you can see how it decimated. If you like it, you apply, and now you have a 1.5 million polygon mesh instead of the 7.5. If you don't like that, then Control Z and just undo it. Okay, I'll open another file just to show you very quickly a little couple of other features, including 3D printing. This was my very first capture. I'm super proud of it because I made it with 2 years ago. It's probably much better now with the same photos that I used to make the 3D print. I did it with a Canon 100S outside in a friend's place. Totally didn't know anything about photography. And it turned out really beautiful. So let's say I want to clean this up exactly to get this 3D print out. But what happens is, here I have something more. If I want to now, clean up this stick here, well, unfortunately, as you see, you always will select something that you don't want. For that reason, we made a feature called Isolate. And the Isolate feature makes it really easy to say, by the way, also just switch to the mesh view. It makes it really easy to say, well, I really want just this. And then I will go back, unisolate, and then I cleaned it up. So let's say I'm not very savvy and I don't know that I cannot 3D print this because it obviously has holes, right? But I'll ignore that and I'll say, no, I still want to 3D print. The software will say, well, for 3D printing, you have to check it, and you have to check zero thickness surfaces and double meshes and inverted normals and stuff. It checks it. It says it cannot be printed. Do you want to fix it? And it starts showing me all the problems that I have in the mesh for printing. It finds 2 holes. I can say, OK, fix them, or I can fix them manually. In this case, I'll just say, well, use the flat method and just fix all the holes. So the software will do the best job to fix whatever it was done. Oh, great, there are no more issues, but this does not look super pretty the way it fixed it, right? So for that, we introduced sculpting tools. And the sculpting tools are simple push-pull tools. And depending on the strength, you can stay longer on one spot, or you can make it stronger, or the size of the brush smaller. But you can start basically fixing the mesh however you want. And finally, if you're ready, you commit. And now we want to print it. It says, let me check if you did it well this time. It will, again, just calculate everything. In the meantime, it will actually start showing you how the 3D print will look like. You're welcome to take a look at this one later. And it's super simple, but I'm super proud because this was 2 years ago, and this is my very first capture. So at the moment, what it is doing, it's loading the 3D print environment. As said, we have about 15 3D printers with their drivers. And we also recognize the size of the 3D print bed, meaning you know maximum how big you can print in certain printer. For example, if I have a Stratasys Object Connects 500, which I do in the office, I can say, OK, I want to auto-fit and see how big can it be in a Stratasys. Or maybe I want to orient it to print it like this. And say, auto-fit, oh, great, I can print it almost 40 centimeters big. Unfortunately, I only have a little MakerBot. If I switch to that and say auto-fit, it will tell me that with the MakerBot, it's about 16 centimeters that I can do. We can also make it hollow here. I'm showing this because it is so frustrating how complicated 3D printing software can be. And we really just wanted to do the very basic of get out a model that looks properly in the printer. But as said, the real deal is that we give the 3D printers the slices directly, so we don't have to decimate these meshes, and they can look really beautiful. I want to show you this one because this is too funny. This was actually a CG modeled hero that then somebody 3D printed, and then somebody else captured. So we have it in the Autodesk gallery in San Francisco. And it is amazing that this is actually a capture with an iPhone 6 of a 3D printed model of this CG character. So it starts really to be funny, the blurring of the digital and analog and digital world, and to play with that. I would like to open a couple of other data sets. This one is close to San Francisco, where I live. It's a battery on Funston Beach. This was a drone capture with a GoPro, but it is quite amazing how it turned out. It will load a little bit. It does take a little bit of time, but you will see also the quality of the texture. So there are also tunnels here, and in order to see them, I will use the same trick with the isolate button that can be used for many different reasons. And now you can see here the quality of the capture. When you look at the navigation mode, we also have a first-person navigation mode. So I can actually, this mouse is a little bit fast, but really look around this capture. What can I show you else? From the data sets. Oh, this is very cute. Well, maybe you will not think so. This is actually from Berkeley. There is a professor who is researching, teaching blind kids, and these are microorganisms that nobody can see, neither us nor blind people. And then they asked a sculptor to actually sculpt it, and we captured it with Artex scanner, and then we 3D printed, we cleaned it up, etc., and then we 3D printed it in rubber so that when you touch it, it's really like a squishy water bear, which is what it is. Recently received some amazing, I would love to show you a little bit of the, okay, this is Chris Anderson, and he will kill me that I always use his head for this. This is a very old capture, and it's not very high detail, but I want to show you this problem. Usually when people take pictures of people, they always forget to take the top of the head, so it always looks really weird, and then you need to start cleaning it up. So how would we clean this up? I can switch to a brush mode, and maybe I'll just start selecting. Now I'm doing this really fast. I'll probably not be so brutal, and I'll select a little bit less, but I just want to show you a couple of tricks here. Okay, I will delete this because this was just interpolated by the software. I deleted way too much, but just to show you the trick of the bridge fixing tool. So we have this bridge tool now that can help you bridge meshes from where they're missing, and it will smartly calculate the surrounding surfaces and propose a shape of the bridge that might be what you need. For that, I will just switch to the single face mode, and let's say I'll pick this triangle and this triangle and say apply. I can do smooth or flat. I'll try smooth. And as you will see, it will create a bridge that actually has the curvature that you would probably expect to do there. And then I can select, if I want to manually fix the hole, I'll just select this and say, okay, just fill this up with this hole filling tool, and it will interpolate it, and then slowly but surely you fix those holes. There are lots of tricks. I cannot show you everything, but this is pretty much that. And I will just open some amazing booth captures. If I see it here, though. I don't. I'll open this, and I cannot tell you yet what it is. I'll just let you admire the scene. We're working on a technology that is upcoming that will produce this level of results. Let it just build up because it is actually quite big. By the way, loading, it's only the loading part is taking a little bit of a moment. It's always less than a minute if you deal with really big data sets, but after that, as you could see, it's really fast to edit and clean up. And but just wanted to show you the quality of this data set. So that's coming very soon. There are some secret recipes there. And let me just try to open the last, and this is a booth capture, and this is processed with an engine that is not yet in, and that is coming in about a month's time. And I just want you to take a look at the level of detail. And the zipper. Yeah, photogrammetry is getting quite close to laser scanning, you must admit. Okay, so I will, I didn't show you the most important thing. Here is the export. So here are the, I better open something that does have a texture to show you that. As mentioned, we can export OBJ with quads. These are not yet the super smart quads where you can define your edge flow, etc. But you can do that later in Matbox. FBX with cameras. When you use decimation, you can select to rebake the texture over the decimated model, and you can select diffuse color map, normal map, and displacement map to bake over the decimated model so that the assets look really, really good. Additionally to that, and by the way, we can export up to Yeah. Up to 8K. The other stuff is what I mentioned, the video. It either has a turntable, automatic turntable, or you can make these keyframes, and the idea is you can say, this is my first keyframe, then I switch up to here, change to this mode, this is my second keyframe, change here, switch to X-ray view, mark keyframe, etc., and just export, and it will do those nice transitions for you. This is more for not savvy people, not for you, but it is kind of neat to do that all in the software. So I would like just to, before I go back to show you some use cases, okay, how do I go in Windows and Explore? Okay, I'll just kill this, I guess. Good. Sorry about that. And so somebody did this in just a couple of hours, and I thought to show you. This was actually a little figurine, plastic figurine on the desk of a colleague of mine. And another colleague just took a picture of that and took some pictures of that, and with some automated rigging, he did this. It's quite impressive that you can do something like this in just a couple of hours, even if I know for your level of quality it's not that, but the idea is that we can really do these things now super fast. So I would like to finish with just a couple of notes on what we work, and more interestingly, what users are doing with Memento or with these technologies in general today. One thing is, yes, we do lots of improvements, the texture improvements, for example. Only a year ago, it looked quite blurry. Now we start to make quite good texture. The mesh engine, the one that is coming in a month from now, it's really, really unbelievably detailed. We always compare with other solutions, and we were better in some cases and worse in others. We were mostly worse in human capture, and now we're definitely better. We've been comparing the latest algorithm, and we're super proud. So let's see what people do with Memento. One of those people is here, Craig. Craig Barr is a dear friend and an amazing artist. He has a company, Polymorphic 3D. He was using very early builds of Memento to make first captures, and he did a 3D model of a friend, and then did a couple of face expressions, rigged it in Matbox, and then really fast could make something like this, which is much easier than just having to model everything, right? What I'm amazed about what he does, by the way, he was working for Autodesk until last year, and now decided that he loves art more than showing and demoing software. And he's doing these amazing handmade sculptures. I will have to speed up because of time, but he's showing the whole process here, how he works on that. And then once he's happy with what he did, he actually is capturing. This video is definitely not the reality, because it would not have been a good capture with that light. It makes it too shiny, but he was capturing himself to show you how he does it. And then he runs that capture through Memento, gets high definition mesh that he then quads and imports in Matbox, and continues developing it further in Matbox. Then he also develops further the textures. For those of you who know Matbox, this is really super easy and super exciting to do. Then used, of course, a lot of Maya for the UV unwrapping, etc., and finally comes to something like this. It's just unbelievable. So artists do not have to use the stupid mice and stuff. That is not the way how they want to work. You can continue working with your hands and then digitize it, and then make 3D prints, cardboard replicas, development for the digital, etc. So what Craig is showing is actually really a new way that analog and digital art can find one world. A couple of different use cases that don't come from your world. A couple of years ago on a 3D print show, I met a guy who was standing next to a huge horse sculpture. And I was like, oh my God, how did you do this? This is beautiful. He said, oh, I made it with MakerBot and with 123D Catch, which is our kids' consumer solution for photogrammetry on the phone. And I said, wait a second, MakerBot makes little ugly white plasticky thingies, and this was big and beautiful and did not look like plastic. So he said, yeah, well, yes, I make the mesh, and then I do split it in many parts, and then print it with a little MakerBot because that's all I have at home. Then I glue it together and apply these amazing materials to make it not look like 3D print. In the meantime, he learned how to take photos better. He graduated to Memento and makes these beautiful captures, goes around museums. He's the one who made that huge, until now, the biggest model that we have, the Winged Victory, and then made it look like bronze or make it look like gold. But actually what he also is doing is he's using new technology and combines them with old way of making things. He makes actually real bronze statues and uses the 3D printout as in a lost wax casting process where he's using the 3D print instead of the wax. And he also makes material look like bone, etc. So by now he has this gorgeous collection of artifacts, and many museums come to him, hey, we're also looking at digitization. We would like that you do some artifacts for us. What's more interesting for me is that he starts to get orders for a life-size 3D printed portraiture by living beings, people who want to leave their legacy and make sculptures of themselves. This is apparently one of the biggest venture capitalists in California, and I assume he put his head on an antique body, so it's more muscly. You know, you men don't exercise so much today, and it looks beautiful. So what Cosmo is doing for me is really a kind of a new form of art, because leveraging technology, he found a way to do art instead of just admiring and invent something new. Then we worked with Sly Lee. It's a young marine scientist from the Hydros. He's focusing on researching corals, and he has very soon realized that there is no scientific method to measure corals, if they're growing or shrinking, etc. So, and we know how important corals are, and yet there was no method to measure them. So he heard about photogrammetry, and basically he started, he got equipment and started doing it underwater photography. And he started early on when we had only the cloud service, before we had a full solution with Memento. And his goal is really to, this is how he dived actually. And the goal is for him to capture, he went to the Maldives before El Nino hit the Maldives, and he's going again after El Nino. And the idea is to compare the assets and be able to actually do this. And we're working together on creating a worldwide coral digital platform where we'll invite divers from all around the world to start contributing their captures, because coral reefs are many, and one person cannot capture all of that, and we can capture over time. He's sharing generously, just like Cosmo, his models and captures so that they can be admired and learned about. This is one of the captures. This is a 3D print. We made a gorgeous 3D print of this, but I just made the same 3D print on our Ember printer that is actually only for jewelry, and it's really tiny, and every hair of the coral still came out in a 1.5 by 1.5 centimeter. So what Sly is doing is inventing a new form of scientific research, right? Then I was very proud that I worked with Louise Leakey. She's the third generation of the famous Leakey family that in Tanzania and Kenya for 6 decades and 3 generations have been dedicating themselves to uncovering, understanding, and promoting the story of our origins. And within those 6 decades, they have gathered thousands of fossils of the first hominids, of the first animals, of the first tools. And unfortunately, all of those fossils are in the Museum of Nairobi, where not many of us go on a regular basis. So other scientists cannot leverage the data. Teachers cannot teach with it. Basically, it's a lot of value, but not a way to share it with the world. So she came to TED, and she saw one of our photo booths, and this was a couple of years ago, asked our CEO, what is this? And he explained, and she said, oh my God, I can find a much better use for your technology. And she started very modestly to do this alone, and then with a couple of students. And by now she has gorgeous replicas of 3D digital models that is ever expanding. And instead of having a website that usually looks like this, a dead photo and then a little bit of text, etc., she's having, this part is a little bit cheesy, but then the rest of the database is really great. She's having this database in 3D of the fossils. For those who know what they're looking for, they can zoom in into detail. They can search by fossil name or by category. We made some tools for comparison, the modern human with some of the first humans. And she's also allowing anybody to download the 3D models so that at school, instead of learning from a book, kids can assemble these cardboard models and compare, oh, that guy had a bigger brain and this one had a flat head, why was that? And really remember. So when you think about it, learning from book or learning from building something, what will you remember and what is more interactive? And this sounds like fun, and it is, but it's actually a new form of education. Almost 2 years ago, I was invited at the Mediterranean Museum in Stockholm. They had an upcoming big Egyptian exhibition, and they wanted to leverage technology to make something amazing. And a company called Interspectral that is specializing on interactive table solutions invited us to join the effort. So we got the body and the sarcophagi of a priest Nesvayu, and we started digitizing. First, we CAT scanned the body, the mummified body, and then we did simple photogrammetry of the cartonnage and of the 2 sarcophagi. And what we ended up with is a digital replica of the entire mummified body, the cartonnage, the first sarcophagi, the second sarcophagi, basically the entire assets that were given to us. And what did we do with it? Well, Interspectral put it on a big table that stands in front of the glass behind which the dusting mummy is sitting. That mummy you cannot touch, you cannot see in detail. This one, you can digitally unwrap, you can digitally slice, you can zoom in into every pearl, into every scripture on the. This project, by the way, was the project why we had to improve our textures a year ago, because it was too blurry for big level of detail, and we did that. Obviously, because we digitized everything, we could also 3D print it, so we have this nice 3D printed replica. But what was super interesting is that we found about 120 hidden amulets under the wrappings of the mummy. And without unwrapping the mummy, we could, because we digitized them, we could 3D print them. And actually, we 3D printed the negatives, and then we casted them in bronze, and we were all wearing those at the opening of the museum. At the opening, needless to say, kids were on it. For them, it was fun, but they were actually learning by interacting. So maybe that's the end of no touch in the museum. We're touching, but in a different way. And we really have much more experience because we interact with the data. And mostly proud of Smithsonian, one of the biggest collections of museums in the world, actually the biggest. They have 19 museums and 137 million objects. And sadly, if you go to museums, all you see is actually only 2%. It's because they don't have enough space. So a lot of the beautiful artifacts are hidden in archives outside of DC or under the buildings in storage spaces. And a young and very dedicated digitization team from the Smithsonian said, we got to do something about it. There is so much wealth of technology out there. How can we use it to actually offer the entire collection? And not only to those who come to museums, but to those who will never be able to come. And the other problem that they wanted to solve is how to make something about teaching, about our history, and making museums appealing to kids who are only interested to look at computers, right? So Vince, Adam, under the guidance of Günther, we call them the laser cowboys. They really started very early, and it was tough. They were testing every single device. There were very few people to ask because nobody was an expert in this. They had to learn by doing it, and they arrived to a wealth of knowledge and started digitizing really high-level, beautiful replicas. And then our paths joined, and they said, okay, we have now this digitization. Can we do something to offer them to the world in an interactive way? And from that collaboration emerged what we call the Smithsonian X3D. It's an in-cloud interactive experience, a space that allows you interactive experiences with all these artifacts. The number one, what we wanted to do is to make the artifacts look as beautiful as they looked in the museum. So let's say this is another video, it doesn't matter. We really wanted the artifacts to look as beautiful. So this is not just a 3D model, a 3D viewer that you can turn around left and right. This was really something that enabled curators to tell a story in a 21st century way without knowing anything about 3D modeling by combining data. We offered measuring tools. So imagine you're a teacher, you're teaching about mammoths. Instead of saying, well, check in the book how big was the leg, you can just measure. This was an artifact that they just had gotten one in the world, Cosmic Buddha, and the relief was very difficult to read because it was very shallow. When we showed the curator that by changing the occlusion map, he could actually read the relief, he was sold. They were like, oh my God. And you can check it. It's called, if you type Smithsonian X3D. I've in my life never worked on something that was so popular. We got people from your industry, hotel chains, branding agencies, everybody asking, can we have this, can we buy it now? And we are very proud to announce that we are working on something that we call Memento Play that will basically enable you in the cloud to create interactive experiences by mixing 3D, 2D, live feeds, drawings, images, audio, video, without any programming knowledge into experiences that you can share with others. So the Smithsonian were pioneers in was to show us the way in the future of the museums and maybe of learning. And really to finish with, digital models have a long life. Not only that, yeah, you can use them in games and films for assets, VR, AR, for learning, for teaching. You can create different types of physical replicas, not just by 3D printing, but with this other method. This was actually a software that I was working on before Memento. It's called 123D Make. It's free software. And the idea is you can put any modeled model or any captured model. All you need to say to the software is, I want it this big, and I have this thick material that I want to build it from. And the software calculates automatically in whatever direction you decided to slice it, the vector pattern. You save it, and then you just plug it in a laser cutter, or even on a normal printer, print it, and then lay it over a material that you want to cut. We also enable instructions. In the case of the gluing method, the numbers of the slices are printed on them, and there are holes for construction so that you know how to glue it together. But there are 4 or 5 other methods. This is a method of what we call interlock that gives you, again, a pattern that is immediately calculated, and if you just decide to make it smaller or the material thicker, it will immediately recalculate. All of these things, when I was an architect, I had to calculate myself, and this is just awesome. And we give you instructions how to do it, because if you don't follow the instructions, you can end up with a puzzle that you cannot solve until the end of your life. Not that complicated, but really. So when we worked on this, we actually did it for kids, but I knew that this will be interesting for architects, for industrial designers, for anybody who, some people use it as a final artifact, some as a base for a paper mache to build characters and stuff. Our CEO is a designer, and he designed this bench out of marble, and then I first made it shylily out of cardboard, but then out of acrylic, and it looks just awesome. And the numbers of the parts are etched on the acrylic, so it makes it look even more beautiful. I made with the same technique a little chair that then produced means gluing manually, real size. But look at this one. This is the same digital model, but interpreted with a third technique, which you can decide to make it, to make a plush toy out of it. It will give you a sewing pattern. You can make it like this with a gun. I forget what was the name of this technique, but it gives you basically parts, connected triangles, and then you have to bend them and with a gun connect them into the chair. You can make a balloon out of these shapes, etc. So it's really interesting how you can have the same digital model, but through different fabrication techniques that are today available to all of us, because this is simple laser cutting that you can get in any tech shop, etc. You can make artifacts that are just beautiful. Why I was showing you this is that, interestingly, software made for one purpose now found another use. Namely, one of the Smithsonian curators was telling us that when they have to change the lights on this beautiful Noguchi sculpture that is big, heavy, and super expensive, they're very nervous about it. And out of joke, we first made a cardboard replica of it, but then we made actually the negative of that, and with interlock technique, we built a crate that is one-on-one just for that sculpture that costed probably about $70 altogether. compared with $2,000-$3,000 a Gibbs one that they usually would do, that is heavy and more expensive, etc. So I love the fact that you make one software and scientists, architects, archaeologists, media entertainment artists, etc. can use it, medical people, etc. Or in this case, we made software for kids, but then it turns out it can be used for other things. I'm wrapping up. We're very proud. Memento was by the users nominated for the 2015 CG Awards in the category of new applications. If you try it and if you like it, vote for us. This week at SIGGRAPH, we are announcing the Mac version. Until now, it worked only on Windows. And it's live, it's beta, it's free. You don't need any cloud credits or anything. Just try it, use it. You can contact me directly, or you can join the forum that you can reach through the website. And thank you very much for your patience. I'm really proud that you came so late on the last day. And I hope it was worth it. Thanks.